Okay, project time. We're going to make Hangman, theoretically. Okay, we're going to make Hangman. Um, so if you know the game Hangman, you know there are a couple of important things that Hangman has to do. We want to be able to select a word that we're going to play with, ask users for their input, check if their guess is correct. If their guess is not correct, we want to have some sort of penalty for guessing incorrectly. We want to keep track of the guesses that they make. If the guess is correct, you kind of want to show where in the word that guess exists, so they can get a sense of what kind of word they're looking at. And then either the user runs out of lives or whatever the penalty is, and the game ends, or they guess correctly and the game ends. So we want to account for both those conditions. Okay, so follow along with me. We're all of these structures, I think, for the most part, you're going to be familiar with now. So try to sort of keep track of them as we go. Also, I want you thinking about kind of the various problems we have to face, because you'll see us sort of break them down into small bits and work them one by one. To start off, we're going to import a couple of libraries that we're going to need. We're going to go ahead and import from the random library, let's go ahead and import a function called choice. What this will do is take a collection and choose one element out of the collection and return it for us. And we're going to go ahead and import OS, which again is going to allow us to clear our screen. So let's first start off by setting up a couple of variables we're going to need for our project. If we want to be able to have a random word that is going to be the hidden word for our game, we're going to need a word bank to choose from. In the future implementations of this, you might consider having a separate file that we load from our hard drive into our script and draw from that so we can get a larger word bank. For right now, we're going to go ahead and just make a words list and then just add some words to it. Make them all lowercase, so tree, hat, class, Python, book, planet, stuff like that, just with a couple of different words that have share some letters but also don't share some letters. That'll give us an example. Now we want our program to pick a random word from that, and we can use the choice function we just implemented. So we can say our word is going to be equal to choice, meaning pick a choice from our words. And now we have our random word that we can play with for our games. That was one of our big steps, was figuring that out. Now we're going to want to track a couple other things. We're going to want to track what letters have been guessed, how many lives our user has left, and whether or not the game is over or not. So we're going to set those variables. We're going to initialize our game state with those variables right now. And we can do it all at once. Basically, guessed is just going to be an empty list. Lives, we're going to set it to some number to begin with. And then game over is going to be set to false to begin with. So guessed, as I said, is an empty list. Lives, give them 10 lives. And game over, nope, not yet, right? So that's false. And there we are, able to implement our initialization of our game state. Okay, we also want a way for us to show them what the word looks like. If you can imagine, if we're not going to do any graphics right now, but you can imagine that if we were going to do this graphically, or if we were to do this on, like, let's say a whiteboard, we might do underlines, right, to show where the various letters are. So how can we do that programmatically? Well, it looks like this. Let's say we want guesses, essentially the guesses they've made, is going to be an array, and in that array we essentially just want underlines, but we want that array to be exactly as long as whatever the random word is, and we know how to get the length of a word now, or the length of an array, a list, and we can use the len. So this is essentially going to set up a list of underscores in a certain order. Right now the order doesn't matter, but it will eventually matter. The length of whatever the word is, whatever the secret word is. And that's what guesses is going to be. Okay, so now let's set up our primary game loop. While not game over, right? We're going to keep track of that game state. If the game is over, we want our game loop to end. But while the game is not over, what do we want to do? We want to get information from the user. We want them to be able to guess. So we're going to say, go ahead and guess is going to be equal to input. And we will prompt the user to type quit or guess a letter. Basically, we're going to set up a way through our input function for them to be able to quit out of the game easily. Let's deal with that first. So if guess is equal to quit, or in fact, sometimes our users get lazy, so let's go ahead and add in if it's equal to Q, game over equals true. And in fact, if we wanted to, we could say something like, well, it doesn't matter. We can just say game over equals true and os.system. We're going to clear, we can clear our game if they're exiting anyway and get them back to a normal prompt. Okay, so now we take input from the user, and if the user wants to quit, they have a way of quitting. What if the guess is in the word? How do we want to react to the guess being in the word? So we say elif guess in word, right? So if the guess is in the word, we might want to say something like right? Some sort of affirmation. Yep, that letter is in the word. And then well, nothing else yet. So that we want to tell them it's in the word. Eventually, we're going to have to like track this. We'll get to that in a second. But let's do that first. Elif let's do else. What if the letter is not in the word? If the letter is not in the word, we want to lives negative equal 1, taking 1 off of lives. We can tell them print sorry, guess is not in the word. And then what happens if they run out of lives, right? We need something to happen if they run out of lives. So as soon as we take away a life, we should check to make sure they have lives left before we go through the loop again. So we'll say if lives is less than or equal to 0. And you might say, why do we have to do less than or equal to? It's just a catch-all. Equal to would probably be fine to check, but just in case we eventually expand this program and we end up taking away 2 lives for some reason, this will catch that and we won't have a bug later on, because there's no reason why -1 shouldn't also cause an end of game state, right? So we can do game over equals true, and we can print game over. Hey, so not bad. We've got sort of a working game here where we're going to basically check if they type quit, first of all, if the guess is in the word, and if the guess is not in the word, what are we going to do, right? Now let's deal with this idea of their guesses, right? So in Hangman, you want to keep track of the guesses they have so that they know. In fact, there's like a lot of information you kind of want to give them. So let's give them some information. So your guest, that's not how you spell guest. Letters. And we would show them what's been guessed so far. Remember, we set that up earlier as an empty list. So we don't always want it to stay an empty list. We want it to start to fill in. But we only want it to fill in if the guess is not in the word. So that's in this else statement here. We can say guest dot append guess. But the problem here is if they oh, huh. Not curly braces, just parentheses. Sorry, that error confused me. We can append it to guess, but the problem here is, what if it's already been guessed before? Okay, well, we kind of need to deal with that too, right? So if, let's do an elif guess in guessed, print you already guessed guess try again. Let's make this an F string. So now if guess is in guessed, so if guess is not in word, but guess is in guessed, this will trigger. By the way, we don't want this to trigger if it's in guessed already too. So we could also say and guess not in guessed, right? We can set that statement. If guess is in guessed, trigger this. If it's not in guessed, if it's not in word, we're going to go ahead and add it to guessed, and we're going to take away a life, and we're going to say, sorry, it's not in the word. And basically, we're going to end the game if they've run out of lives. So that gives our user the information about what they've guessed so far. Let's also give them information about how many lives they have left. Lives. And then let's also give them some information about the word they're trying to guess. And what we know so far, all right, let's rethink this for a second, because this actually is a new thing you haven't done before. If you think about Hangman for a second, typically, here, I'll do it as a comment. You might have, if I was trying to guess the word paper, you might have P underscore P underscore R, something like that, right? And that would say, okay, I'm missing 2 letters in between the P's and the R. So we want to be able to set that up somehow for our user to be able to see. Which reminds me, we should make sure that our input is always lowercase. Let me do that quickly before I forget. But that means we need to kind of do something when they do get it right here. So when they get the word right, we should keep that. We should keep that for reference, and we should do something with that. So once we print that the guess is in the word, we want to say for I in range. We're going to set up a loop here. The loop is going to go through the whole length of the word. And it's basically going to say if some letter in word is equal to the guess. So every time we come across a letter in the word, starting at the beginning of the word, going to the end of the word, right? So we're looping through the word here. Every time we find our guess in our word, we actually want to change our guesses array by replacing essentially one of those underscores with the actual guess. Now, how are we going to end this if they successfully guess the entirety of the word? And how do we sort of combine guesses so that it reads in that sort of letter underscore letter fashion? This is the trick. So if word equals, we're going to use an empty string. We're going to say dot join. We're going to use this join function, and we're going to pass it our collection of letters and underscores. So if word, I did the assignment operator. I should have done the comparison operator. If word equals all of the guesses kind of squished together, then that means the guesses are the word, meaning they've guessed every letter in our word. We should print you win. And we should set game over to true. we also want to be able to show them the word as it exists with their guesses in it, with that sort of underscore fashion that we were doing. So we're going to print an F string again, and we can say word to guess is going to be equal to dot join guesses. Okay, that's not going to work because of the double quotes in here. This becomes problematic. So we have to set up a separate variable. We'll call it hidden word. Set that equal to this empty string joining the guesses like that. And then we can just set this equal to hidden word. Beautiful. Okay. Let's try it out. All right, we haven't guessed. You've guessed no letters. Word to guess. It looks like it's 4 letters long. I'm gonna guess the letter T. Okay, T is not in the word. I still have 4 letters to guess. Let's try P. P is not in the word. This is great though. You see that it's keeping our list of words letters there. That's great. Maybe an A. Should we check an A? No. How about an O? Great. So we now know O is in the word, and it's 2 O's in the middle, followed by a first letter and a last letter. I'm going to type BK. Okay, BK is not in the word because it's more than one letter, but B is and K is. So that's another little error we need to fix. And notice how cluttered our screen is getting. We should probably clear this every time the user does an input. So let's do os.system, and we'll clear it. That'll make the screen look a little bit nicer. And then let's give our user a little bit of space to input their letter. Something else I noticed is this like crowding here. But then let's deal with this double letter thing. Else if, right, elif, length of word, or length of, sorry, guess, right, what they've guessed, is greater than 1, print guess 1 letter at a time. All right, now we've done some cleaning up. Your guess letters. Okay, word to guess is 4. Let's guess that O again. It looks like we're going to end up with the same word. Fine, good, it works. I wonder if that'll keep happening. Okay, no. Here, automatically, we've got a longer word. Looks like it begins with a P, Y, T, H, N. Doesn't work, right? Guess 1 letter at a time. We could guess T. T is in the word, but we've already guessed it. We could guess D. D is not in the word. We could guess it again, and it says you already guessed D. Try again. Great. And we could say Q and quit out of our program. Beautiful. This works great. We will return to this project later on as we learn more about functions and whatnot. I want you to take a moment and really appreciate what we've just done. You've created a Hangman game, and if this is your first time doing any coding in a course like this, you've come really far and you've done some great things. So I just want you to take time to appreciate how much you've done and how much you've learned over a very short period of time. So you should be really proud of that. Great job. We made Hangman, and we'll return to this in the future and do more things with Hangman. But we're gonna move on. Great job.